All right, welcome to the Explainer. Today, we're diving into something super important, securing your serverless apps on AWS Lambda. When you're not managing the servers yourself, the whole security game changes. The old playbook, yeah, you can pretty much toss that out the window. So, what are the new rules? How do we keep our stuff safe?
And that really brings us to the central question, right? In this serverless world, who's actually locking the doors? It's so easy to think, oh, AWS has got it covered. But trust me, that is a dangerous assumption. So let's figure out exactly which security keys are in your pocket and which ones belong to AWS.
So the place we have to start, the absolute foundation of security on AWS, and this is true whether you're serverless or not, is this idea of a partnership. It's not all on AWS, and it's definitely not all on you. It's what we call a shared responsibility.
Now, this partnership has an official name. It's the shared responsibility model. And honestly, the best way to wrap your head around it is to think about renting an apartment. AWS, they're the landlord. They're responsible for the whole building. The foundation, the security guards at the main entrance, the physical structure. But you're the tenant. It's still your job to lock your own apartment door and make sure everything you put inside is safe.
So this really breaks down into two super clear areas. On one side, you've got AWS. They handle the security of the cloud. We're talking about the physical data centers, the concrete, the servers, the core Lambda service itself. Then there's your job, security in the cloud. And that's all about your code, your data, and this is the big one, managing who you actually let in the door.
Okay, so let's tackle that first big responsibility you have. Managing access. We need a gatekeeper, someone or something to control exactly who and what gets to talk to our Lambda functions.
And that gatekeeper, my friends, is AWS IAM, Identity and Access Management. Seriously, just picture a bouncer at the coolest club in town. That's IAM for your application. Before anyone or any service can even think about interacting with your Lambda function, IAM is right there at the door, checking their ID, checking their permissions. And if you're not on the list, you are not getting in. Simple as that.
Now, when you're setting up IAM, there is one golden rule you have to live by, the principle of least privilege. This is so critical in serverless. Why? Because one single function with too many permissions can become a massive security hole for your entire system. So you never ever give a function the master key. You give it only the specific tiny key it needs to do its one job. If a function's only job is to read from the orders database, well, that's the only permission it gets. Nothing more and absolutely nothing less.
So how do you actually put this principle into action? Here are the must-dos. First, please don't use your root account for everyday work. That's like walking around with a master deed to your house in your back pocket. It's just too risky. Instead, use IAM roles to give your functions temporarily rotating credentials. And for any actual human being with access, you have to enforce multi-factor authentication, or MFA. It's probably the simplest and most effective security layer you can add.
All right, so we've secured the front door, the bouncer's in place. Now, let's talk about what's inside our club, the code itself and the data it's handling. We need to lock that stuff up in a secure vault.
Okay, so how can you be 100% sure that the code you're deploying is actually your code and not some sneaky malicious thing that got slipped in? The answer is code signing. It's a really straightforward three-step process. First, you digitally sign your code. Then you tell Lambda, hey, only trust code with this signature. And finally, Lambda becomes the enforcer. Every time you deploy, it checks that signature, kind of like a wax seal on an old-school confidential letter. If that seal is broken, tampered with, or just plain missing, the deployment gets rejected. No questions asked.
Okay, let's switch gears to the data itself. Your data really only exists in two states, right? It's either moving around, we call that in transit, or it's sitting still, being stored somewhere. That's at rest. And here's the bottom line. Both of these states have to be protected with encryption.
So for in-transit data, think of an armored truck. It's all about protecting that data as it's traveling to and from your function. And the great news here is that Lambda's own API endpoints enforce this for you by default with HTTPS. Then you have at-rest data. This is your bank vault. It's about securing stuff that's just sitting there, like your code packages or your environment variables. And again, this is another spot where Lambda has your back. It encrypts all this for you automatically.
Okay, so we have our foundation, we've got our gatekeeper, we've built our vault. That's awesome. But trying to check all these things manually, especially when you have hundreds or thousands of functions, it's impossible. It's just not going to happen.
That's where we need to bring in automation. We need to build some guardrails to keep us on the right path automatically.
And this is a really fundamental shift in thinking. You stop being a manual inspector, checking things off a list, and you become an architect of automated systems. The real goal is to build these guardrails that automatically check all your work against your security policies, before you deploy, during deployment, and even after. It's a continuous cycle.
And AWS gives you some fantastic tools for this job. First up, you've got CloudFormation Guard. This one is proactive. It checks your templates for any rule violations before you even think about deploying. Then there's AWS Config. It's kind of both preventative and detective. It can check your setup before and after you deploy. And finally, there's Amazon Inspector. Think of this as your 24/7 detective constantly scanning your deployed code for any known vulnerabilities.
And really, that's how it all comes together. It's a simple 4-part security framework for Lambda. You start with the foundation, understanding that shared responsibility. Then you post a gatekeeper at the door using IAM and the principle of least privilege. Next, you lock everything up in the vault with code signing and encryption. And to tie it all together, you build automated guardrails that watch over everything and keep you compliant.
And that just about wraps it up. I know we covered a lot, but the main thing to remember is that security isn't something you just set and forget. It's a process. It's ongoing. So I'll leave you with a little challenge. Take a look at your own projects. What is one security guardrail, just one, that you can automate this week? Thanks so much for joining us for this explainer.